All right, well, hello everyone, and welcome to this final exam review video. So our goal for this video is to provide a brief overview of what to expect on our final exam and to provide some extra practice to help you prepare. So here's our goals for today's video. First, we will briefly review topics and what to expect on the final exam. And second, I highly recommend that you open up your IDE and code along with some example programs. One of the best ways to prepare for exams in programming class is to write programs yourself and verify that you understand how to use all the tools that we've covered in this course. I also highly recommend that you check out our previous videos and our previous lectures on additional topics that you might want further review on. You can also check out our prior exam review videos for more examples and practice on the topics from earlier in the course. So let's go ahead and get started. First, just in terms of formatting, you should expect that the format of our final exam will be very similar to the midterm exams that we've had in the class. And so there will be some kind of simple multiple choice type questions, and there may be some kind of short answer, fill in the code, identify the bug type questions. And there also will be some short answer questions where you might need to write a function or a very short program. And please also be aware, for the purpose of the final exam, there will definitely be a pointer question and a linked list question similar to the drawings in our assignments and similar to the examples that we have covered in the lecture. So I highly recommend that you have pencil and paper handy in order to complete a pointer and/or a linked list question. Very often it's helpful to draw pictures as you solve those questions. So please make sure you also watch our class updates for additional details regarding the final exam, and be sure to check out our study guide for a full list of topics that will be covered. All right, so before we move into the review portion of this video, I'd like to remind you about my top recommendations on how to prepare for the exam. And please note, my number one recommendation is that to get better at coding, you need to write code yourself. So as much as possible, practice and prepare for the exam by coding. Play around with the sample programs that we've covered, our homework assignments, and other programs from our book. Try modifying them or recoding things from scratch without looking at the solution in the book. One of the best ways to test your understanding is to sit down and pretend it's the exam and see if you can code up a working program from scratch, covering the topics that we've learned. Also, remember, our assignments and quiz questions cover topics that I think are most important, and so very likely you're going to see something similar on the exam. Also, our study guide lists the full topics covered on the exam, so be sure to review all the topics on the study guide. And if you have last-minute questions, remember you're welcome to reach out by the usual channels in order to get help. Finally, drawing pictures and practicing with tools like pythontutor.com can be very helpful, especially when working with pointers and dynamic memory. All right, so with that, let's go ahead and get started with our review. So once again, just a reminder that I personally think the best way to prepare for these exams is to write programs yourself. So I highly recommend, as you go through this video and these practice programs, I recommend that you consider pausing the video and trying these programs yourself. You'll notice that the practice programs we're about to do are fairly short, and many of them we're just going to write out by hand without even needing to open an IDE. And so it's really good practice to see if you can reproduce these programs without relying heavily on notes or on lecture materials. So let's go ahead and get started. We'll briefly review each topic, and we're going to focus on topics covered after the midterm exams. But please note that if you'd like additional review from topics before the midterm exams, you can also check out our prior review sessions and earlier lecture notes. Please note that our final exam is cumulative, but there will be emphasis on the newer material covered after our most recent exam. Let's start out with this first practice program. In this practice program, we are given a working test program for this function called fizzBuzzToFile. You might remember we had a homework assignment where we did a question similar to the FizzBuzz interview question. We also covered the FizzBuzz interview question in our lecture on loops. So in this practice question, we are given the declaration for fizzBuzzToFile, and our task is to write a definition for this function so that it will produce the desired output. So let's briefly review what we need to do here. We'll notice that fizzBuzzToFile takes the name of a file as an argument, as well as the values for a starting and ending integer. Notice this function assumes that our include headers needed for reading files are already present. When this function is called, it's going to open a file and output whole numbers, starting at start num, ending at end num, following FizzBuzz rules. So it's going to write the FizzBuzz outputs to the data file name. And we're given a main function that will call this fizzBuzzToFile function, but we need to write the definition so that this function will work properly. So this is actually a fairly straightforward program to write, and it requires knowledge from the first portion of our class. If you're rusty on file manipulation or functions, I'd recommend you check out our previous lectures. I also recommend that you try coding up this example program and following along with me in your IDE. So let's go ahead and try coding up this practice program, and let's verify that we can make a working fizzBuzzToFile function. Alright, so here I am inside CLion, and you can see that we have our starter code, including our fizzBuzzToFile declaration. We have our main function that tests the fizzBuzzToFile function, and I have written an empty definition after my main function. So I need to fill in this definition with the code so that fizzBuzzToFile works properly. So in this case, let's go ahead and start by declaring our output file stream objects. Remember, we need to write to a data file, so we need to use our output file stream object in order to write to that data file. So here, I'm just going to go ahead and declare an output file stream object named outFile. And I'm going to use this just like cout in order to write data to the file of interest. You'll remember I need to use the open function in order to open the output file and start writing data to it. So I need to use the dot operator here and say outFile.open. And in this case, I want to use file name, the name of the data file where my output should be written. Remember, this file name is the file passed into the function from main. So now that we have opened that data file, we can now create a loop to perform the FizzBuzz output. You might remember the FizzBuzz output looking something like this. Where we had a for loop starting at 0, ending at some other value, and incrementing by 1 each time. But remember, in our instructions, we want to specify the starting and ending numbers. So in this case, rather than having my loop counting variable start at 0, I'm going to have it start at startNum, because that was the first value passed into my argument to specify where FizzBuzz should start. Similarly, my FizzBuzz should end at endNum. And I'm going to go ahead and assume that we want to go all the way up to and including endNum, so I'm going to go as long as I is less than or equal to endNum. So the way I have set up this loop, I am going to start at my integer startNum and increment by 1 until I reach endNum. Inside my loop, I need to apply the FizzBuzz rules. Remember, the FizzBuzz rules are, if the number is a multiple of 3, output fizz, and we're going to output fizz to the data file. If the number is a multiple of 5, then we output buzz to the file. And then finally, if the number is not a multiple of 3 or 5, then we output the number to the file. You'll remember we learned a clever approach for doing this program. The clever approach is to use well-designed if statements to check each case without brute forcing it. So first we can just check if I modulo 3 double equals 0. If my number is a multiple of 3, then, remember we're not using cout here anymore. We want to write to the data file, so we write to our out file. We simply need to output fizz. Next, if the number is a multiple of 5, we're going to output buzz. And notice here, if my number happens to be a multiple of both 3 and 5, both of these if statements will trigger. So there's no need for me to have an additional if statement to capture when both 3 and 5 are multiples. We would automatically get fizz buzz in that case. Finally, we capture the case where we are not a multiple of 3 or a multiple of 5. So we need to use AND here. So if I'm not a multiple of 3 and I'm not a multiple of 5, then I just output the number itself. And in this case, I also want there to be a new line between each output, so I'll just do one last output to add a new line between each output. And there we have it. Notice this was actually a fairly simple program, very similar to the example we did back in our loop lecture. Let's go ahead and run this thing. So let's run our main function and see if this program works as intended. So our main function is going to prompt the user for the file name, a starting number, and an ending number. So maybe I'll just call my file name output.txt. Starting number, how about number 12? And ending number, I don't know, maybe 35. And notice I got my message here that the output has been written, and all of a sudden this output.txt file has appeared in my project directory. If I open this output, well, would you look at that? I started at number 12. Since 12 is a multiple of 3, we got a fizz. Fizzbuzz happened at number 15. And notice we went up to and including number 35, where we ended with a buzz. So therefore, we have successfully implemented the fizzbuzz-to-file function. And notice how we needed to use the values provided in the function argument. We put those in our function definition, and we directly used file name, start num, and end num in order to output the user's desired results to the appropriate file. If you haven't already done so, I highly recommend that you try coding up this program yourself. Verify that you're able to reproduce the same result that we did. Alright, so let's go ahead and move on to our practice question 2. I mentioned that on the final exam, there's going to be some sort of pointer question. So definitely make sure you understand how to solve questions using pointers and pointer syntax. And remember, if you would like additional practice with pointers, please check out our additional videos, including our past pointer lecture and our videos containing more pointer practice problems. You'll remember from our previous video, I like to use a convention where I put pictures to help me keep track of what's happening. And I like to put the variable's value inside a box. I put the variable's name on the left-hand side, and I like to put the variable's memory address on top. So this is the convention that I follow when drawing memory. You don't have to follow this convention if you learned another method or prefer a different way. This is just one approach that I prefer. But regardless of the strategy you use, I highly recommend drawing pictures to help solve these pointer problems. So let's go ahead and try this practice. So in this program, we initially declare several variables here. We have a pointer named A. I'm just going to give it an asterisk. A second pointer named B. A third pointer named C. Then we have a variable named lucky number. And we also have another variable named mystery number. So if we go ahead and read through this program line by line, let's see what happens. We first declare A and B are pointers, and we don't initialize them yet. We make C point to a new int. So our pointer C is going to be holding the memory address of some new integer. Then we initialize lucky number to hold the value 7, and mystery number is initialized to 10. Now let's continue reading each line of this program, and we'll update our pictures to keep track of what's happening. First, we have this code C equals ampersand mystery number. So what that means is our pointer C, instead of pointing at our new int, we are abandoning this new integer, and instead we're making C point at the memory address of mystery number. So this new integer just got abandoned. Next, we have our pointer A. We're writing A equals ampersand lucky number. So that means we're making our pointer A point at lucky number. So the pointer A is storing the memory address where lucky number is stored, and I'm drawing an arrow that points at lucky number to remind me that A is pointing at lucky number. All right, so we've completed those first two lines. Next we have B equals A. B is also a pointer. So if we say B equals A, that means we're going to make B hold the same thing as A. That means B is also going to point where A points, at lucky number. In our next line, we have asterisk B equals asterisk A plus lucky number. So that means we're going to go where B points, and we are going to assign the memory the value that A is pointing at plus lucky number. Well, what's A pointing at? Well, A is pointing at lucky number, so asterisk A is going to be 7. And then lucky number, well, that just holds the value 7 as well. So we are going where B points, which is lucky number, and we're going to update this data to now hold 7 plus 7, or 14. In this next line, we have A equals new int. So in this case, A is no longer going to point at lucky number, and A is going to point now at a new int. So this is some other new integer that we've just created in dynamic memory. And in our last line of code, we have asterisk A equals asterisk B plus asterisk C. So that means we are going to assign our new int the same thing that b is pointing at plus c. So b is pointing at the value 14, asterisk b gives us 14, and c is pointing at mystery number, or 10. So in this case, this line of code, asterisk a equals b plus asterisk c, that is going to give our new int the value 24. We've now reached the end of this program, and if this were an exam question, you would need to fill in the blanks to what these cout statements would output. So now we can look at our picture and determine what the cout statements would give. And here we see that asterisk a, that's the thing a points at, that gives us 24. Asterisk b, well, that's giving us 14. B is pointing at lucky number. And asterisk c is going to give us the number 10. And mystery number is also the number 10. So our expected output would be 24, 14, 10, and 10. And it turns out, if you were to run this code in a compiler, that is exactly what you would see. So I highly recommend that you go back through this example and verify that you're able to trace the pointers and understand the pointer syntax. This is really good practice. So if you'd like more review of pointers, please also check out our previous examples for some longer pointer questions, including ones that have function calls. So it's definitely fair game for me to ask some pointer question requiring you to track memory and draw pictures, as shown in these examples. Alright, so these next examples are formatted kind of similar to an exam question, where you wouldn't have an IDE in front of you to code up the actual question, but you should know enough about classes and objects and functions that you would be able to write a function definition in order to implement part of a class. So in this practice, you're being asked to write a function definition for the getMagicNumber function. This getMagicNumber function is a member of the ppmImage class. You can see that the ppmImage class contains some private variables, including magic number. And then the ppmImage class also contains a bunch of public functions, such as a constructor, getter and setter functions, and also some additional functions that we will implement later. So in this first practice, we're given this class declaration, and we need to write a function definition for the getMagicNumber function. Remember, these definitions should be written as if we were coding the class in the implementation file. So in this case, let's assume that we are writing our code in the implementation file, which would be ppmimage.8 or ppmimage.cpp. So we should assume that we already have access to the class declaration and all the include headers that we need. All right, so let's go ahead and take a look at what getMagicNumber should do. getMagicNumber is a getter function. And notice the post condition, it should return the value of that private variable. So if I ask you to write a get or set function on the exam, you should be pretty happy because these functions are quite easy to write. You can actually code up the entire getMagicNumber function with one line of code. Let's go ahead and write this out. Remember, since we're in the implementation file, we need to include our scope resolution operator. So we have scope resolution operator and then our function name. And remember, the getMagicNumber, it should return the private variable magic number. So in this case, we can write this function with a single line of code. We just simply say return magic number. And that's it. So the important thing to remember here is to remember all the different rules we learned about declaring and implementing classes. Since getMagicNumber is a member of our ppm image class, it can directly access our private variable magic number. But we do need to remember that scope resolution operator in the function's header in the definition. Let's try another practice for the ppm image class. In this example, we are now asked to write a function definition for the setRValue function. Let's see what this function is supposed to do. You can see that setRValue has an argument for row, column, and new red. So this function will update the value of the red pixel at the specified RGB values location to be the new value. So in this case, remember our ppm image class actually contains this array RGB values that is made out of pixel structs. And so we actually need to go into the RGB values array and update the red value at the specified index. This is actually a pretty straightforward function definition to write. Let's give it a try. So once again, we need to include our scope resolution operator. And now we need to add the code inside this function that will update the pixel at row col to be new red. So we need to update the pixel in RGB values. Notice RGB values is our private 2D array, so we need to update that pixel in RGB values row col to have red is equal to new red. So how would we access RGB values inside our class? Well, this function already has access to RGB values. Because this is a private variable, so we can go ahead and say RGB values row col, but now we need to specify This is a pixel struct. So in this case, we need to tell our program to access the red values. So we need to say RGB values row call dot red equals new red. So notice we need to use the dot operator to access the red value inside RGB values row call pixel struct. So notice this function definition allows us to update just one value at 1 pixel. So make sure you remember how to use the dot operator correctly in this function. Let's try another practice. In this practice, we are asked to write the function definition for the default constructor of the ppm image class. So let's take a look at what we are given for this default constructor. In this definition, or in the preconditions and postconditions of the declaration, we are told that we should set magic number to P3, width to max calls, height to max rows. We set max pixel to 255, and we initialize all pixels in our RGB values array to red, green, and blue are 0. So basically, we need to initialize all the private variables of our ppm image class to these desired values. So remember, the purpose of a default constructor is to initialize our private variables. So here we just need to initialize the variables as specified. Let's go ahead and write up this definition. So notice, we still need to include the scope resolution operator on our default constructor. All right, so let's go ahead and initialize our private variables as specified. So remember, we do not want to redeclare private variables. So in this case, for example, our first private variable we need to update is magic number. So we need to update magic number to P3. But notice, we do not want to redeclare magic number. We want to update the actual magic number private variable that our constructor is being used on. So please make sure you remember we update the existing private variable magic number to be equal to P3 as specified. Notice we also need to update width to be max calls. We update height to be max rows. We set max pixel to be 255. And now we need to update all the pixels in our RGB values array to be 0, 0, 0. Can we just go like this? No, this won't work, right? Remember, to update the values in our array, we need to use nested for loops. to manipulate the data in our array. So please make sure you remember that. So in this case, let's go ahead and write some for loops. So we'll need to go through each row and through each column. So in this case, I'll go ahead and start with I less than 0, I less than max rows. Or we could even just go ahead and say height if we wanted, because we've already initialized that. And then j would be less than our width. And now inside our nested for loops, we need to set each pixel in that RGB values array to be 0. So in this case, we need to go ahead and say RGB values ij dot red is 0. RGB values ij dot green is 0. And finally, RGB values ij dot blue is 0. So notice, this code will allow us to update each pixel as instructed and to update all of our private variables as specified. So if you're rusty on arrays or PPM images, you could also consider checking out some of our previous videos covering arrays and applications of arrays. You'll definitely want to be comfortable using for loops to manipulate arrays and using the dot operator to access data within an array. So with that, we have successfully defined our default constructor, and you'll notice that it is correctly updating all of our private variables to the desired values. All right, so let's now suppose that we want to add a new member function named getAverageRedValue. And so this is a brand new member function that we would be adding in to our PPM image class. And notice what this function is doing. We're told that we are given an object with all its values initialized. And our post condition is we want to return the red value, the average red value for each pixel in the image. So essentially what we're saying is if we have a PPM image object, notice we'll have some private variables like magic number. Let's go ahead and write this. So we'll have magic number, width, height, max pixel, and then we'll have our RGB values. Suppose I had just 4 values in RGB values. Again, it could be more depending on the values of width and height, but let's just say that we had 4 values. So our RGB values could be like 255, 0, 0, 0, 0, 0, 1, 1, 1, or 5, 10, 20, right? Like each of these RGB values is a single pixel struct. So here, if I do get average red value would return the average of all the red values in RGB values. So here our red values would be 255, 0, 1, and 5. So in this case, the average would be 255 plus 0 plus 1 plus 5. That is 261 divided by 4. So let's go ahead and try writing up some code for this function. So once again, we're assuming it is a member function, so we'll go ahead and treat it as such. So we'll give it the scope resolution operator, and we'll call it, oops, we gotta include, it returns a double type, notice. And now we need to write our code. So notice, essentially what we're trying to do here is we're trying to find the sum and the number of values inside our array, and then return the average back to our main function, or back to whoever called us. So in this case, we need to declare some variables to help us calculate that average. So I'm going to go ahead and declare an int value named count, and also a double variable named sum. And because I'm going to be doing math with these, I'm going to initialize them to 0 initially. I now need to go through every value in RGB values and add the red values to calculate my cumulative sum. So let's go ahead and write some for loops to do this. Remember, we're assuming our width, height, and RGB values are already initialized. So in this case, we can go ahead and use our existing private variables in order to help us do this. So we'll go ahead and we'll loop over each height, so that'll be our rows, and then our width will be our columns. And inside that for loop, we need to calculate the sum of all the red values using a cumulative sum. So what we can do is we can write that our sum is equal to the current red value plus the existing sum. So here we have sum is equal to sum plus RGB values, element I, j dot red. This code is going to add the RGB values red value at each index to the cumulative sum. And then we need to increment count in order to keep track of how many values we read. Once we've finished that, all that's left is to return our average. And in this case, it'll just be sum divided by count. Notice I made my sum a double type, so my average will not be subject to truncation errors. So that's all there is to it. This is the same approach that we learned for finding the sum and average of values in an array, We just had to use the dot operator in order to access the data inside of a struct. All right, let's go ahead and do one last example on this ppm image class. Another thing we talked about in lecture was overloaded operators. So here, we want to add a declaration and definition for the overloaded equality operator, or double equals. So the declaration has already been provided. And you'll see what this overloaded operator is doing is it is comparing two ppm image objects. So essentially we have one ppm image object that'll be our current instance. Remember that this pointer points at the current instance, and we want to compare it to a second ppm image object named other. Or in this case, we named it image. So each of these ppm image objects is going to have a magic number. We're going to have a width, height, a max pixel, and the RGB values array. So both of these objects have their own values inside. And so we want to return true if both objects have identical values for all private variables. So we need to have same width, height, max pixel, magic number, and all values in RGB values array are the same. So we need to return true if both objects have identical values for all private variables. Otherwise, we return false. So our goal here is to compare the current instance with image and determine whether or not these two ppm image objects are identical. So let's go ahead and code up what this overloaded equality operator would look like. So we start with our header. And remember, of course, we still need our scope resolution operator. And it takes a ppm image named image as its argument. So remember, our goal here is to return true if everything is exactly the same, but if we detect that any private variables do not match between the two objects, then we immediately return false. So we can actually accomplish this task using not too many lines of code. First, let's go ahead and compare the values one by one. We can have an if statement, and we can say if my current object's magic number is not the same as image's magic number, Or I can also check if width is not the same as image's width, or if my height is not the same as image's height, or if max pixel is not the same as image's max pixel. If any of these things are not the same, then we know our two image objects are not identical. So we could go ahead and return a false if we detect that something doesn't match. So we've checked most of the private variables now, but we still need to check that RGB values array. Can I just say if RGB values is not equal to other.RGB values? No, that won't work. Remember, we have to compare arrays element by element. So to compare the values inside my RGB values array, I have to use nested for loops again. So in this case, I have to write some for loops. So we go ahead and we say, all right, let's go ahead and check. If we want, we can check all the way through max rows and max calls just to make sure there's not anything fishy even outside the desired range. And now we need to check if our RGB values element I, J is not the same as images pixel. If my two pixels don't match at that location, then I return false. So if one of my pixels doesn't match, I have to return false. All right, and finally, if that for loop has ended and we have not detected anything not matching, then we know if everything matches all of our private variables, including our pixel array, if everything matches, then we go ahead and we return true. So notice how well-designed if statements and for loops and return statements made this overloaded equality operator not too challenging to code up. All right, let's finish up our review with a few practice programs related to linked lists and node-based data structures. In this practice question, we're asked to write the default constructor for a stack class. And notice that in this case, we're told that the default constructor should initialize our object to be an empty stack. And our stack is made out of these nodes called stack node structs. And we see that our stack contains a single pointer So each stack object contains a pointer named top, which points to the top of our stack. So in this case, our default constructor should initialize the stack object to be an empty stack. This is actually a really easy question, because if our stack is empty, where does our top pointer point? Remember, our head or top pointer will point to null if the stack is empty. So it's possible to write this default constructor definition with just a single line of code. All we need to do is make that stack pointer top point at null. If we also had some variable named length, like if we had a variable here named length that kept track of how many items were in our stack, then maybe we would also need to say length equals 0, but in this case we don't have that. We just have a single default constructor and a single pointer here, so we just make top point to null. Let's try another one. In this practice, we're asked to write the definition for the function isEmpty. And isEmpty will return true if our queue is empty. Well, how would we know if a queue data structure is empty? Remember that a queue data structure has pointers that point kind of to the front and the back of the queue. So in this case, our queue is empty if both front and back point to null. We can actually write this function with a single line of code. This single line of code will return true if front and back both point to null. That tells us that our queue is empty in this case. Now remember that we did write up some function definitions for the other functions in this queue and stack in our previous lecture videos. So it would also be very good practice to try coding up the function definitions for the rest of these functions. And if you'd like to see that explained, check out our previous video on data structures for an explanation. Let's try one last practice before we end. In this last practice, we are asked to write the definition for the print function. So we should assume that this is a member function of our queue class. And notice the print function should output the queue's data to the screen or return 0 if the queue is empty. So in this case, we'll just output 0 to the screen. Let's go ahead and code this up. So it'll be a void type function. and it's a member of the Q class, so we'll go ahead and treat it as such. So in this case, we first need to make sure our queue is not empty. So if we had already defined that empty function, we could simply output 0 and then exit. Or we could, if we did not have the empty function declared, then we could just repeat that code that we had before. So if front points to null and back points to null, then in this case, we would output 0, and then we would exit. In this case, you could also use a return if you wanted to go back into the function that you called. Okay, so we captured the case where we output 0 if we're empty. Let's now consider the case where our queue is not empty. If our queue is not empty, we need to read through each node one by one and output that data to the screen. So let's declare a pointer named cur to step through the list and output the data. So I'll go ahead and declare a QNode type pointer named cur. And that pointer should initially point to the front of my queue. Then I can use a while loop, similar to what we learned. And as long as my current pointer does not point to the back of my queue, then all I need to do is output current arrow data, and then I need to advance cur. So current equals current arrow link to advance to the next node. So notice when our loop ends, we will have stepped our current pointer through all of the nodes of our list until we reach the end, and we would have outputted each of the values to the screen. So this print function would output each node one by one to the screen. And if we wanted, we could add like a new line or some formatting in there. But otherwise, our print function is complete. So this concludes our review session for our final exam. And I hope you found these videos and this course to be a really helpful introduction to C++. Thanks so much, everyone, for watching. And feel free to reach out if you have any other questions as you prepare for the final exam. Thanks again for a great semester, and I hope to see you in another class or in another video sometime soon. Take care.